Welcome to this eLearn Security video training lesson on owasp Z-Attack Proxy, also known as ZAP. ZAP is one of the most popular web proxy tools, and it is already installed in Kali Linux. We can open it by clicking on Applications, Kali Linux, Top 10 Security Tools, and then select ZAP Proxy. This is going to launch ZAP. Just wait a few seconds until the ZAP GUI appears on the screen. The first thing to do when using a web proxy is to configure the browser and the proxy to work together. We can easily do this by clicking the Plug and Hack button here. Plug and Hack is a proposed standard from the Mozilla security team for defining how security tools can interact with browsers in a more useful and usable way. Since it is still under development and it does not always work smoothly, we're going to set the proxy configuration manually. By default, ZAP uses a proxy listener with address localhost and port 8080. Although this configuration may work in most cases, we can still edit these settings by clicking on Tool, then Options, and select Local Proxy. Note that there are a few shortcuts to directly open this window. We can click on the wheel here or press Ctrl+Alt+O. As we can see in this window, we can set the address for the proxy listener as well as the port. Right below, we can also set a few other options to set security protocols to intercept. For now, let us use this default configuration and click OK. The next step is to configure our web browser in order to use the proxy listener just set in ZAP. To do this, let's open Iceweasel, the default browser installed in Kali Linux. This is very similar to Firefox. Indeed, we can set the proxy by clicking on the top right icon, then Preferences, Advanced, Network, and click on Settings. Here, let us select Manual Proxy Configuration and type the address and the port previously set on ZAP. Moreover, let us check the box Use this proxy server for all protocols and click OK. We're almost done, and ZAP should be able to intercept the request and the responses from our browser. Let us try to navigate google.com. As we can see in the address bar, we are trying to navigate an SSL website, but the browser warns us that the connection is untrusted. This happens because we need to accept the ZAP SSL certificate. Installing it allows us to browse all of the SSL websites without getting any warnings. Let us go back in ZAP and open the settings window. This time, let us select Dynamic SSL Certificate. From here, we can generate new SSL certificates, import certificates, but also inspect and save them. If we click on View, we can see all of the details about the current certificate. For example, this one is a root CA certificate, and here we can inspect all of its information. Let us close the window and click on Save to export the certificate. Now we have the certificate stored on our machine. Let us go back into our browser and import it. To do this, we have to open the Preferences panel, then move it to the Certificate tab and click on View Certificate. Now we can import the certificate just saved by clicking on Import and then selecting the first of the following three options. Now we are good to go, and we can navigate any website, even HTTPS addresses, without getting any warning. Let us try to open google.com once again and see what happens. As we can see, this time it loads correctly. And if we switch back in ZAP, we can see all of the requests and the responses organized by domain. Now that everything is set, let us inspect the ZAP user interface. On the left, under the Site tab, we have the tree window which allows us to navigate around the URLs visited. Each domain is organized in a folder and contains all of the requested pages of that domain. We can simply navigate them by expanding the tree. Moreover, by right-clicking on an element, we can select a specific operation to run. For example, we can run different attacks, delete the item, include it in a context, and so on. We will inspect some of these features later on. On the right side, we have the Workspace window. Here, we can see and manage the requests and the responses for the relative element selected on the left tree. Note that the header and the body are separated, and we can select them to display as text or hex. The Break tab allows us to change the requests or the responses content on the fly, but we have to enable to break point for them. We will see this in a moment. Let us continue inspecting the information window, located at the bottom of the interface. Here we have many tabs, each one with a specific purpose. In this video, we are going to inspect few of them. The History tab allows us to navigate through all of the requests made. As you can see, if we select one of them, the workspace window changes according to the request selected. The Search tab allows us to search in all of the requests and the responses. We can search specific strings in the whole request or response content, or filter the search for specific parts, such as URL or headers. Another useful tab is the spider. If we run the spider, here we will see all of the URIs found during the scans. Note that we can run the spider from here by simply selecting the domain to scan and click on the play button. Here we can also run the spider scan from the tree window. We just need to right-click on the item we want to scan, select Attack, and then choose one of the following spider options. As we've already said, there are a lot of tabs and features here, but we're not going to inspect them all. Instead, what we're going to see now is how to set breakpoints on requests and responses in order to be able to modify them on the fly. Before enabling this, we may want to define a context containing a set of URI allowed for our tests. In other words, which of these URIs are in scope and which are not. This allows us to run a potentially dangerous action only on the domain specified. Let us suppose we want to run our tests only on the targetapplication.site domain. So, let us first go back into the browser and navigate it, so it will appear in the tree view. To add this domain in our scope, we can right-click on this item, select Include in Context, and then choose a default context or create a new one. For now, let's create a new context. A new window appears, and here we can configure all of the context settings. First, let's give it a meaningful name by clicking on the first item in the tree on the left. So let us call this context with the same domain name of our target website. Also note that here we can easily set the context as in Scope Item or Not. As you can imagine, we can define more contexts and then select which of them are in scope. In the Include in Context item, we can set a list of rejects to define all the URIs in the context. This was automatically added when we selected Include in Context, and it is a simple regex that defines the URL for the target application.site. In the same way, we can exclude URIs from the specific context. For example, let us suppose we want to test only a specific folder or area of the website. Here we can set a list of URI that will be kept outside of the scope. For now, this configuration is enough, so we can click OK. As we can see here, items that are in the scope have a target icon in the tree window. Now that we have specified our target and our scope, we need to tell Zap to work only on in-scope items. To do this, we have to click on the drop-down menu here and select Protected Mode. Here, Safe means that no potentially dangerous operations are permitted. Protected allows us to perform operations only on URLs that are in scope. Standard means that we can do anything we want to on all URLs. Therefore, with the current configurations, we will work only on the targetapplication.site domain. To test if this is working, let's first enable the breakpoints for each request and response by clicking on these two arrows. Now, every request and response will be intercepted by Zap before being sent to the web server or to our web browser. Let us go back into our web browser and try to navigate a URL that is outside of our scope. If our configuration is set correctly, we should be able to navigate the website as usual. Here indeed, we can navigate it without any problems. Let us now try to navigate the in-scope URL. Remember that we have set the breakpoints, so Zap should intercept the request before sending it to the web server. Indeed, as we can see, the browser is still loading, and if we go back in Zap, we can see the request in the Break tab. Great, our configuration is working fine, and we can now inspect and edit each request and response to and from the target website. Here, for example, we can change the value sent and forward the request by clicking the arrow on the top menu. Since we did not type in the correct credentials, the web server redirects us, and indeed, we can see another request coming from our browser. Let us forward this one too. Here we have the response of the web server. As we can see, it redirected us to the login page once again. As we already mentioned, we can edit each request and response. For example, let us try to change the following string and forward the response to our browser. If we go back into our web browser, we can see that the content of the page is changed according to our edits. Now that you know how to properly configure Zap, your browser, and use some of the Zap components, we suggest that you keep using it in order to test its features by yourself. If you want to dig deeper, please consider using the Zap User Guide. And this concludes our training video lesson on OWASP Zap. Thanks for joining us.